With the latest versions of the software, calculating electromagnetic fields alone is not sufficient. Our customers now need to couple electromagnetic fields to thermal calculations to see how the temperatures are going to vary through the device, stress calculations to see whether the device is going to blow apart. And this is quite difficult because not many engineers are educated in the full range of analyses that are necessary to complete the design of the device. So, I mean, the software has to help. The software has to contain sufficient knowledge of all the applications to help the engineer get solutions which he perhaps doesn't have the background to really solve by himself.
It's quite interesting that we increasingly find that actually people are being asked to work in electromagnetics who don't have the electromagnetics background. So it's necessary for us to actually provide the tools that will address the complete, what's now comes to be termed as multiphysics problems. Although we've always said that we are providing multiphysics tools for the electromagnetics designer. I mean, that's still our message.
Yep.
We're providing the stress analysis, we're providing the thermal analysis to assist them because we know that it will influence the performance of their particular devices.
And it means we have to have the skills in-house to be able to do that, to understand the applications well enough to embed that knowledge within the software. And collaborations are important in that still. I mean, we need to be involved with our customers to develop our knowledge of their applications in order to contain it within the software.
Yeah, I guess the prime example of that was working with Oxford Instruments and Siemens Magnet Technology on the Quench software. Now, if ever there was a closely coupled electromagnetic and thermal problem, and to a lesser degree a stress problem as well, then that's it. And representing those superconducting materials is a real challenge, because there's so much going on at a very small level. But you have to be able to solve a realistic problem with it as well. So the homogenization of the materials was a great idea as a way to do it.
I mean, I've been involved with the quenching of superconducting magnets throughout my whole career, both standing
intentionally
near them,
or not,
standing near them when they quench, and then trying to simulate it. And it's fantastic how the development of the software has enabled us to better and better represent quenching magnets. Even something introduced 2 years ago in the software, the thermal barriers. These are dimensionless thin layers between finite elements. If you use those, you can achieve much better representation of complex coil structures than we could before, and our results for quench analysis suddenly become much cheaper to obtain and much more accurate.